Okay, 3. So use the factor theorem to show that 2x plus 3 is a factor of this function above. Okay, so according to the factor theorem, guys, it literally tells us that if we let this linear term equal 0, so in other words, 2x plus 3 and set it to 0, and find a solution of x, well, in this case, x would be, well, minus 3 over 2. And if we substitute this value x into this function, then we should get no remainders. So in other words, guys, let's plug in f minus 3 over 2 into the equation. All we literally do is replace all the x values here, guys, with minus 3 over 2. And if you do for every single case, you should come up with a result in your calculator that should be 0, yeah? So just double checking. And when you write this, put this on the calculator, and again, your answer should be 0. And therefore, we say 2x plus 3 is a factor of fx. That's it. There's literally nothing to it. We know it's going to be a factor because it actually tells us to show that it is indeed a factor. So honestly, guys, don't bother working out. You're going to get 0 for sure. Now looking at B, it says, hence, using algebra, write fx as a product of 3 linear factors, okay, given that we already have one factor. So essentially, guys, we have a cubic equations and we need to break it down to 3 different brackets, yeah? Now, the easy way to do this, yeah, because we know 2x plus 3 is a factor, we could just use long division. So let's try out here, yeah? So we've got part B, and we're now going to do 2x plus 3, and we're going to do a long division on, let's copy out the top equation, 6x cubed, so 6x cubed plus 17x squared plus 4x minus 12. Okay, so we're going to do this step by step here so we can understand every single part. Now, the way long division works, guys, and it's just like normal division, you look at the very first term and you ask yourself, how much does 2x go into 2x cubed? Well, we just do a division. We just say, alright, 6x cubed over 2x. If we're going to divide this step by step, 6 over 2 is 3, and x cubed over x is x squared. So you're going to put this result up here, okay, right above the x squared column. And a little note, guys, always line up your answers in terms of powers, yeah, so x squared here, x, and constant here. Now, step 2, what you can do next is use your result and times against this bracket here, so 3x squared times this linear part. When you do that, you should get an identical result of, again, 6x cubed, but this time plus 9x squared, okay? And now all we do is subtract these two, yeah? So subtract these two values, and when you do that, well, 6x cubed take away 6x cubed is nothing, 17 take away 9, and they both will x cubed, you're going to get an 8x cubed. And then that's pretty much the main idea. And next you would have to drop 4x down, so you're going to get plus 4x. And then once again, guys, just rinse and repeat. So look at 2x and see how many times that goes into ax squared. So just right on the side, ax squared over 2x. Well, that should give us a 4x. So we're going to write that result up here. And again, we're going to now use that 4x and multiply against that linear term, basically repeating everything. 4x times that will give us another identical result of ax squared, and this time plus 12x. And yeah, so we just keep doing this. And then subtracting these two, 4 take away 12 is going to be minus 8x. Again, these x squared terms always cancel out. And now we just drop minus 12. So it'd be minus 8x minus 12. And lastly, we do the same thing. How many times does 2x go into minus 8x? Well, we just do minus 8x divided by 2x. Simplifying the result, you get minus 4. Okay. So that minus 4 again goes right to the top. And just to wrap it up, we're going to do that. We're going to use that minus 4 and multiply that linear term to get another result of minus 8x minus 12. And the cool thing about this, guys, is that because you know that they are all factors, your remainder is always going to end up becoming a 0. If you don't get 0, then it's probably best to check what went wrong. So we can now say that fx now equals the linear term, 2x plus 3, times the quadratic term, which was 3x squared plus 4x minus 4. Okay, so factorizing the second part now, and we'll be done here. We should get a result of something like this, yeah? So it should be 2x plus 3, and then the first bracket should have a 3x, and the second bracket should have an x, yeah? Why? because we know that 3x times x gives us 3x squared. Now we just need two numbers that multiply to get a 4, yeah, to get a minus 4. And the only two values I can think of, well, two pairs would be 1 times 4 or 2 times 2. Out of these two pairs, we need to multiply one of these digits, either 1 or 4, by 3 to give us some difference of 4. Well, that's not actually possible. If we multiply one of these 2's by 3, let's say, well, this one by 3, we're going to realize that 2 times 3 is 6, and 6 and 2 has a difference of 4. So that means you can say, alright, 3 times 2 is 6, and put another 2 here, we can get 4. How? If we get 3x times plus 2x, this gives us a 6x, minus 2x, and we're done. This gives us our final result. We now need to solve theta, which is given in radian modes, the following equation, yeah? So, in fact, you know what, just taking a moment to look at this, we can see that this equation, which is now in terms of tan theta, is actually the same as the x equation above, isn't it? The only difference now is that x has been replaced with tan theta. So x equals tan theta here. And now, because it's equal to 0, they actually want us to solve this, yeah? So the best way we can do this, guys, is to actually use our result from part B, the three linear factors. Instead of solving for x, we're going to solve for tan theta. So let's start with that, yeah? Let's go ahead and use our answers from part B. So just looking at this one for a second, this is, if we just let this equation equal 0 now, and this is going to be part C, yeah? We pretty much can get three solutions here. If you look at the first one, we have 2x plus 3 equals 0. We found that earlier that x here is pretty much minus 3 over 2. For the second part, x would be, well, you can add 2 across and divide 3, so it would be equals plus 2 over 3, or x here could equal negative 2. That means, if I'm going to scroll down for a bit, and one more bit down, this means that tan theta is actually equivalent to minus 3 over 2, or tan theta is equal to plus 2 over 3, or even equal to minus 2. So you actually got three different results now. Now, to get the value of theta, we just have to tan inverse, yeah? So in your calculator, it looks a bit like that. It's just this little button here. And to get it, you go press Shift Tan. So inversing each of these results, guys, you should get values of minus 0.983 for the first one. Second one, you should get 588, or also minus 1.107. Okay, so at this stage now, we need to see whether these values fit the range, yeah? Now, if you remember in the question, it said that theta, the values of theta are only allowed between pi over 2 and pi. Now, if you don't like how this looks, what this actually means, and if you want, you can replace pi with 3.14. Pi over 2 is actually 1.57, and pi, of course, is 3.14. So they want answers between this range. And as you can see, we ain't got a single one. Now, how do we get them? Well, two ways. We could use the cast or quadrant method, but that's a bit long. The second method is to also just realize that for tan graphs, and that's just by sketching, yeah? To use a tan graph, we should realize that every single 180 degrees, it just repeats itself, like forever. So what it's trying to say here is that if you had a result on this value here, that means if you add an extra 180 degrees, you get another similar result here, and so on. So essentially, to get other results, we can keep adding 180 degrees to our actual result. But because we're working in radians, we can't use 180 degrees. We've got to use pi, because in radians, 180 is the same as pi. So that means, guys, for every single answer here, to get additional answers, keep adding pi. So for the first one, if we add pi here, we would actually get 2.16 in our calculator. If you add pi for this one, you would actually get 3.73, which is outside our range. So far, 1 is good. And lastly, if you add pi over here, you'll get another answer of 2.03. And yeah, guys, I think that's really it. If you want additional answers, again, you can add an extra pi or an extra pi and so on. Or if you want to go backwards, if you want to go back through the tan, you can subtract pi. But for the purpose of this question, they just want answers between these values. So our final answers are 2.16 and 2.03. Now, figure 1 shows a sketch of the curve with equation y equals 2x squared plus 7. Okay, so this is just part of the curve. And it says that the finite region R, so the shaded region, is bounded by the curve that we see, the y-axis up here, and also a line y equals 17. They want us to find the exact area of R. So the easiest way to compute the area of R is to actually divide into two shapes here. And the first thing is to realize that this can be formed as a nice rectangle here, going downwards. And one other property is the fact that if we had to integrate this expression here, we could actually find the area under the curve. And that's what happens when you integrate and set limits. You actually end up finding the area under the curve right up until the x-axis. So this is the area we would be finding. Okay. Now, to find out how far to integrate, well, we need a limit. We're only going to integrate up until this line here, but we don't know what this value of this line is. The only thing we do know is that it hits at y coordinate of 17. So what we could do, we could use this equation here, plug in y equals 17 and find x. So let's do that for a second. Let's try and find the x coordinate here. Yeah? So we say, okay, when y equals 17, we now have 17 equals 2x squared plus 7. So just subtracting 7, we got 10 equals 2x squared. And then we could just divide by 2 to get 5. And then square root to get x equals root 5. It's only going to be a positive root 5 because it's going to be on the right hand side of the graph. And it tells us that x is greater than or equals 0. So now we know that this is root 5. We can now realize that this is just a nice rectangle with an area of, well, the base here is root 5, the difference is root 5, and the height is 17. So we can say that the area of the rectangle is just 17 times root 5, which is actually just 17 root 5. So that's the whole area. However, to get the region now, we need to subtract this rectangle from the area under this curve, yeah? So let's do that, yeah? To do that, we can say, alright, therefore the region itself is the area of the shape, which is 17 root 5. And we're going to minus it against the integral formula, which is the integral from 0 to root 5, because that's how far we're going, of this curve. So we're going to use the curve as a baseline, yeah? And the curve equation was 2x squared plus 7 and then dx. And yeah, guys, if you could just evaluate this, then you're done. So evaluating this carefully, so let's have a look. Now, to integrate this one, the rule is that you always increase the power by 1, then divide it, yeah? So I'm just going to put a big bracket so we don't mess this up, yeah? So this would be a 2x cubed over 3. If it's just a constant, add an x, so it'll be 7x. And because you've got limits, which are 0 and root 5, you just put them up here, root 5 and 0. Now, to use limits, guys, all you do is just plug in the upper limit first, so replace all the x as root 5, then subtract it with x when x is 0. So it'll look something like this. We're now going to have 17 root 5 minus, so first we use the root 5, we're going to have 2 bracket root 5 cubed over 3 plus 7 root 5. Okay? And then we're now going to minus it when x is 0. Well, when x is 0, they're both 0. So in fact, we don't even need to write that. We can just delete all this. Now, at this stage, we now need to simplify this carefully. Okay? 17 root 5 minus, now going to have 2. Well, root 5 cubed is actually 5 root 5. 5 root 5 times 2 is going to be 10 root 5. So this would be minus 10 root 5 over 3. As we're expanding the bracket, this becomes a negative 7 root 5. And now this is all easy. Now we're just collecting like terms, yeah, in terms of root 5. So if we just factorize root 5 for a second, yeah, we basically got root 5 outside, and now we got 17 minus 10 over 3 minus 7. If you put all of this in your calculator, guys, you'll get 20 over 3. That means our result is now 20 over 3 root 5. And yeah, that's the end of this question. Alright, number 5. So in this question, you must show all stages of your working. Solutions relying on calculator technology are not acceptable. Okay, so what it's trying to say here, guys, is that you can't just use some kind of equation and just get the answer without showing proof, okay? So I'm going to show you guys the proof of how to do this question, yeah? So let's begin. Now it says that a colony of bees is being studied. The number of bees in the colony at the start of the study was 30,000, okay? 3 years after the start of the study, the number of bees in the colony is 34,000. Okay, so it's increased by 4,000. A model predicts that the number of bees in the colony will increase by p% each year, so that the number of bees in a colony at the end of each year of study forms a geometric sequence. Alright guys, so essentially they want us to pretty much form a geometric sequence, but an easy way to do this, guys, is to use a particular formula which I like to use. I call it the OVNV formula. That is, that you have some original value, increases by some rate, let's say 1 plus some rate p, for some number of years, and it should give us a new value. Well, in this case, we know that the original value is 30,000, and we know that, well, we don't know what the rate is, that's what we're trying to find, but we know this lasted for 3 years, and then we ended up with 34,000. And yeah, all you can do here, guys, is literally just rearrange and find the value of p. So to do that, I'll divide 30,000 across, so I'll be left with 1 plus p to the power 3. Well, 34,000 over 30,000, that just simplifies to 17 over 15. And then you could find the cube root of this, and then subtract 1. So therefore, you can say p equals the cube root of 17 over 15, and then minus 1, and you actually end up with a p result of roughly 0.0426. And because they want p as a percentage, well, you can say therefore p is actually 4.26%. And that's it, that's literally A done. As for the next part, it says according to the model, at the end of n years, so now instead of 3 years, we've got capital N years, the number of bees in the colony exceeds 75,000. Okay, find, showing all steps in your working, the smallest integer value of n. Okay, no problem. So an easy way to do this is literally use the same approach. Now we can say that the original value is still 30,000. 1 plus p is literally 1.0426. We don't know how many years because they said capital N, and it's supposed to exceed 75,000. But we're just going to use the equal sign for now, yeah? So no big deal. Now all you want to do here, guys, is the same thing, except now we're trying to find n. So to do this, first divide 30,000 across. You're going to have 1.0426 to the power of n equals all of this over 30,000. That's just 75 over 30 basically. And now I would just take logs here, guys, yeah? Because to find n, you need to take logs on both sides. So take logs, you have something like log 1.0426 to the power n equals log 75 over 30. Now, a very useful property of the logs is that when you got power inside the expression, it goes in front of the log. So it looks a bit like this. So it becomes n times log, and then you got 1.0426 equals log 75 over 30. And now all you do is literally drop that thing across, so divide the log term to the right. You're going to have n equals log 75 over 30 over the log 1.0426. And then just drop that in the calculator and you should get an end result of 21.96. And they said something about the fact that we need to find the smallest integer value of n. And well, because we know that it exceeds 75,000, so essentially we could say that n, therefore, so I should correct this, therefore n exceeds 21.96. This means that n has to be 22 because that's the smallest possible integer after that number. And that's it, guys, we're done. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go onto my channel page, hit the subscribe button and hit the bell for more notifications, and if you want, you can do personalize or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.